Example 3, I'm going to change the problem slightly. Well, drastically, I guess. 1 squared plus 2 squared plus 3 squared plus dot 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 plus n squared equals n times n plus 1 times 2n plus 1 over 6. All right. So we're supposed to show that that statement is true for all values of n such that n is greater than or equal to 1. We're talking about the positive integers. So it's still the same. All of them are pretty much the same. You start with step 1. Show S1 is true. So for S1, look at the first statement, the first term, the first sum, 1 squared is going to equal 1. Then look over on the other side and plug in n equals 1. If you plug in n equals 1, you'd have 1 times 1 plus 1 times 2 times 1 plus 1 over 6. Clean up, that's going to be 1 times 2 times 3 over 6. That's going to be 6 over 6, which is 1. So you got 1 equals 1. That works out. S1 is true, so we're good for step 1. We've shown that the first domino falls. Step 2. Show SK true leads to SK plus 1 true. So we start with an assumption. Hope I have enough room here. So just take the original statement and replace the n with a k, and we're going to assume that's true. So we're assuming there's some domino that's going to fall down. And now we need to prove that the next domino will fall. So on the left side of our statement, it looks like we're copying it down. But we actually have to go one more, okay? The next term added on there is just going to be k plus 1 squared. The right side of that statement, change all your k's to k plus 1s, and you're going to have k plus 1, and then k plus 1 plus 1, and then 2 times k plus 1 plus 1, all over 6. Now again, that's a question. I don't know if that's true or not. That's what I'm trying to show. Okay. So the first step is oftentimes the same. Part of the assumption is in my step, okay? That part of the assumption you can see is equal to, look at the right side of my purple step, k times k plus 1 times 2k plus 1 over 6. All I did was a substitution, substitute the part that we know is true, that we assumed was true, into our left side. And you can kind of look at the left, look at the right. You see that maybe they're going to be equal, but we've got a whole lot of algebra to do. All right, whole lot of algebra. We've got some distributive property, we've got some FOIL, all kinds of things that we're going to need to do. So here, let's distribute this k. And I see k squared plus k times 2k plus 1 over 6. All right, I can, this is going to be k plus 1 times k plus 1. I'm going to have to FOIL that, and if you could FOIL that in your head, that would be awesome. Okay, you're going to get k squared plus 2k plus 1 once you FOIL that out. So even better, it looks a lot, it looks like it's going to match up with that right side, I suppose, but we're still going to have to clean some stuff up. I'm going to FOIL this, and I've got 2k cubed plus k squared plus 2k squared plus k over 6. And I'm going to take this and get a common denominator 6 here. I would have plus 6k squared plus 12k plus 6 over 6. I'm trying to get common denominator here. I will add the like terms. There's a 2k cubed. I see some k squared like terms. That's going to make 9k squared. Now we got some k plus 12k, that makes 13k. Plus that 6, all over 6 there. All right, so we want to see if that matches up with the right side. So let's clean up the right side. I've got k plus 1 right here. And in this set of parentheses, k plus 1, that's k plus 2. And then over here, let's distribute the 2. That's going to make 2k plus 2 plus this 1. We're going to call that 2k plus 3 over 6. All right, still can't tell if it matches. We're going to need to FOIL some stuff together, multiply some stuff together. So let's do that. If you distribute here, that'd be k squared. Well, I can do FOIL in my head. First is k squared, and then you go outside is 2k, and inside is 1k, so that's going to make plus 3k. And then last, 1 times 2 is 2. All right, then we've got a bigger distributive property. You can't really call it FOIL anymore because there's too many terms, but it's basically the same idea. It's distributive property. So if we distribute, that's 2k cubed plus 3k squared. And then you distribute this one. That's going to be 6k squared plus 9k. And then you distribute this one. That's 4k plus 6 plus 4k plus 6 over 6. Combine those like terms. I see 2k to the third. I've got plus 9k squared plus 13k plus 6 all over 6. All right, so after all of that, now we can see that they're equal. Left side equals right side, so we just did it. Okay, that's exactly what I wanted to do. I've just shown that that domino falls. If I assume that some domino falls, I proved that the next one falls. And what that does is that proves every domino falls. And so I can wrap this up and say, therefore, Sn is true for all positive integer n.